Welcome again, and today we're going to learn about the structure of an atom, but instead of basing our learning with the actual model, which is the quantum model, which we'll learn more in other videos, we're going to base the learning of this video with Bohr's model, which is a much simpler model, which enables us to learn about the basic characteristics of the subatomic particles that we find in an atom without having to learn complicated stuff. So first of all, we're going to talk about the three main subatomic particles. We have the neutron, the proton, and the electron. We find both the neutron, the proton, in the nucleus, which is very dense and small, whilst we find the electrons orbiting around the nucleus in what we call shells. The two main characteristics that we need to learn are the charge of the subatomic particles and the mass. Before doing anything further, we need to know that when we talk about charge and mass, we're only talking about relative. So when I say that a neutron has a charge of 0, or when a proton has a charge of +1, I'm not talking about that they have a charge of +1 coulomb. It's only relative to the other subatomic particles that we talk about. Okay, so the charge of a neutron, as its name says, neutral, is of 0, whilst it has a charge, a mass of 1. The charge of a proton, positive, +1, while the mass is of also 1. And finally we have the electrons, which have each a charge of -1 and a mass of nearly 0. But instead, it's 1 over 1,836, nearly 0. Now we're going to talk about the quantity of each of them. We know that atoms, let's put it here, atoms are neutrals, particles. So we can say that the number of protons must be equal to the number of electrons, since both of them have a charge with the same magnitude but with a different sign. So both numbers have to be the same. Now let's talk about the properties of elements. So imagine we have element X. Here we would have two different numbers. Letter A corresponds to the mass number, which is basically the number of protons plus the number of neutrons, since these two are the main mass of the atom. Then we have letter B, which defines the atomic number. This is simply the number of protons, but because atoms are neutral, we can use this formula up here to show that the atomic number defines P, but also E with atoms, not with ions, because remember, ions have charge. So if they asked us to calculate the number of neutrons, the only thing we would have to do is A minus B, since that would be P plus N minus P, which gives us N, which is finally what we want, the number of neutrons. We also have to know what the term isotope means, what they are, and how to apply it to problem solving. So atoms are basically atoms of the same element, but with one exception. It has a different mass, but with a different mass. Here comes the problem. Since atoms are neutral, we can't add more protons. So what we do is we add more neutrons. Okay, so let's give an example of two isotopes. Two isotopes would be carbon-14 and carbon-12. In this first example, we found that carbon has 8 neutrons, whilst it only has 6 protons. With carbon-12, it has 6 neutrons and 6 protons. We see that this one has 2 more neutrons. So they must be isotopes because they are atoms of the same element, carbon, but with different masses. It has a mass of 2 more. So that's all for today. We have learned a few things. We have learned, for example, the structure of an atom using Bohr's model. We know the basic characteristics of the 3 subatomic particles, the neutron, the proton, and the electron. We have discovered that the number of protons and electrons in the same atom must be the same, provided that atoms are neutral. We talked about the mass number and the atomic number and how we can calculate the number of protons, electrons, or neutrons. We also talked about isotopes, what they are, and we gave an example to illustrate what they are. Thank you for watching, and I hope you have learned something new.